So I'm Michael Ducy. I work at Chef. I do product marketing, but don't be afraid that you have a marketer up here in front of you. I have a long background in technology. I've worked at Chef for 4 years. A lot of stuff in the open source community for a long time. Used to do a lot of stuff in the cloud stack community as well. And you can reach me on Twitter if you want, right there, MFDII, which are my initials, by the way. So we're going to talk about simplifying container operations with an open source project that we have at Chef. So Chef actually has 3 open source projects that we maintain. The one that we're known for, Chef, one called Inspec, and another one called Habitat. And I'm going to talk about the latter one, Habitat, today, and how it can help with container operations. So agenda, we'll talk about some of the problems in the world of containers. Give you a quick overview of Habitat, well, not a 30-minute overview of Habitat, how Habitat makes containers better, and then hopefully we'll have time for some questions and answers. If you don't get your question answered, or you don't have an opportunity to ask it, we do have a booth upstairs, which I'll be at afterwards, as well as several other people from Chef as well. If you want to take a picture of this real quick, or if you want to look at any of these links while I go, here are the useful links that I'll also put up at the end as well. But if you have your laptop open or something like that and you just want to check out what I'm talking about while I talk about it, some useful links for you. So yesterday we saw, did everyone get that? All right. So yesterday we saw this during the keynote. I forget who did the presentation, but it was one of the evening keynotes, and she talked about how we've kind of progressed from using a broom to a vacuum, and now Kubernetes is like a Roomba, right? And Roombas are cool because you can just have them go around, and it feels really good because you don't have to do much work anymore. So what do? Just sit back, kick your feet up when the Roomba comes through. And it's pretty awesome, right? And Kubernetes and containers and schedulers and kind of the new world of technology definitely starts to feel that way. So this is kind of like you when you're starting to playing around with Kubernetes and you're like, get out of my face, enterprise ops team. And you just, just kind of think you're the shit. And then you kind of maybe take it to the next level and you throw on a shark suit and you're like, yeah, I'm badass with what I'm doing with containers and Kubernetes. And then, enterprise ops, of course, wants to try and get in on the party. So they put on, all they think they need to do is put on a shark suit as well. But the reality of the situation is a little bit different, right? So this is actually a video online. I just took some screen caps instead of just showing and playing the video for you. You'll be able to search for it after I tell you what's actually going on. So we can see here we have a dog, and the dog is relieving himself in the, this is actually a really common problem. Well, dogs having accidents, but what I'm going to show you is a common problem. And then the dog, as all dogs do, kind of sniff it to make sure, he's like, oh, where'd this poop come from? And then he's like, oh, I guess it's mine. But this is actually a really important thing. So I've had a long history of colon cancer in my family, so you should always look down in the toilet to see what's there, just to make sure you're not bleeding or anything like that. So a little awareness we're all getting older in age, some of us in here. So you just want to make sure that you're paying attention to those things. And then, of course, it's time to vacuum. And the Roomba just is coming through and doing its thing, right? And of course, what's the Roomba going to go do? It's going to pick up the mess. And of course, it's probably a little moist. And sure enough, there goes the Roomba. And there you go. You have a nice new clean floor, don't you, right? And of course, that's kind of your feeling when you're messing around with new technology, and especially technology in the container space and the scheduler space. It makes you question all of the assumptions that you've had of how you've been doing operations and development for the last 20 years, right? And all of the paradigms that we've had for many, many years are not the same anymore. And we kind of illustrated this. This is a coworker of mine who I tweeted and stole credit for his drawing. But we call it kind of this cliff of learning, right, when you have containers. And we're not picking on Docker intentionally. That's what we happen to write on the whiteboard. But you could replace that with containers in general, right? The packaging format. And it's, as Kelsey Hightower likes to point out, it's a lot more about the packaging. It's much more than the packaging format, right? Containers are just a packaging format. What you have to think about is the actual operational concerns that you have around containers and running this packaging format, right? So some of the things that you see as you start to ask yourself, how do I run containers effectively in production? So one of the things that you hear a lot of is, how do I decouple the application build from the final production-ready container? And a great example of how you do that, there's a project called Rocker, which lets you have one container image used for the build, and then you can create your artifacts. And then after that, you can actually take that artifact and put it into another container image. So that's an example of how you can split your build from your actual running container. Anyone ever like do an apt-get install and you got to put in core utils and GCC and all these other things, and then you don't remove them in the end and you just ship it on into production? That's what we're talking about, splitting the build from the actual production-ready container. How do you build immutable infrastructure? So one of the cool things that we always talk about, and especially early on when containers were getting out there and becoming more popular, is like immutable infrastructure, immutable infrastructure. And if you've done any level of operations for any point in time, you know that's complete bullshit, right? Because, are we allowed to cuss during this conference? All right. I've already done it several times. We know that it's crap, like the Roomba example, is because there are all these environmental things that you have to inject at runtime to change the running configuration for the environment that you're actually going and running in. One solution is you could create 5 different container images for each different environment. You could use environment variables to change configuration settings. That gets tricky when you're going to start putting secrets into environment variables, which is a bad idea, right? So how do you do those things? I'll talk about how we address that problem with Habitat. How do we orchestrate the application launch order and topology required? So Kubernetes is really good at making sure the containers are up and running. But once the containers are up and running, there's actually something inside of that container that needs to be orchestrated as well, and that's the application itself, right? So how do I have the application come up in maybe a certain clustering topology and other things like that? And then also, this is another thing, and you see this with the shift to Alpine Linux that's happened over the years, is how do you build containers with a minimum viable OS? How many people build containers with a minimum viable OS? Which basically like make the container image as small as possible. So a few hands went up. How many have container images that are like 4 gigs? You don't need to raise your hand because I know there's probably a lot of you in the room. Gareth Rushgrove from Puppet actually did a really good talk at Config Management Camp in just back in February, which Config Management Camp is a conference that's held in Ghent over in Belgium. And he did some data and looked, and over 70% of the container images that he was querying and looking at have a full-blown operating system inside of that container image. So ponder that for a second and kind of think about what that means. Especially from a perspective of you having stuff in there that you don't even need, right? And also from a security and attack vector space, and the more stuff that you have in that container, the more ways that you could possibly have your machine exploited, right? So let's talk about Habitat by Chef. So Habitat is one of the open source projects that we maintain, as I said. It's a new project that we started in, when we started it maybe about 2 years ago, but we made it public in June of 2016. And there's a really good video where Adam Jacob, our CTO, and one of the main creators of Habitat goes through and talks about it more on a little bit deeper computer science level, maybe doctoral dissertation type level, maybe not that deep, but closer to that. I'm going to give you a higher level overview of what that looks like and what Habitat is. So if you think about how we build and run, or how you want to build and run modern applications, and especially in a continuous delivery context, what you want to be able to do is you take a source code repo, that source code repository goes through CI and a CD pipeline, you end up creating that artifact gets stored in an artifact repository, and then you're going to go and run that artifact on a variety of different platforms. It could be, and depending upon your needs, right? So bare metal, you might want to run it inside of a container, a cloud instance, or a VM in your own data center, right? So we call this kind of process, or this cycle, is how do you build, deploy, and manage your application? And Habitat focuses on each one of those areas in a different way. So the first thing that we do in Habitat is we create what's called a plan. So we have a plan, and it's called a plan.sh. And if you're at DockerCon, if you're going to be at DockerCon, stop by our booth, and we're going to have a great sticker that kind of takes that truck. Everyone knows what that van is, right? It's the A-Team, right? All right, so this is what's called a plan. And so a plan is written in bash, right? So it's a .sh. And why did we choose bash as the language for this? Well, how many people know Python in the room? How many people know Ruby? How many people know Perl? Right? How many people know bash? Right? So now we get a more consistent set because like half of the room knew Ruby, half of the room knew Python, but everybody knows bash, right? So it's very accessible and approachable. And so what we do here is that we're going to basically name, these are just metadata that we're setting up. We have the source code repository that we're going to pull the source code from. We have our build dependencies, and our build dependencies are, of course, different than our runtime dependencies, and so we have glibc. So what this is going to do is when you run this plan through, it's going to go and run make, and it's going to build the binaries for Redis, right? And we'll get the Redis binaries packaged up for me. So compare this with a Docker file, right? It's very kind of a similar concept. However, instead of starting with an infrastructure component or an operating system, I'm starting with the application and then defining what the applications need, and then go from there, and then resolve dependencies down versus this other method of where you kind of resolve the dependencies top or bottom up. And I'll talk about that here in a second. So when you take this plan, you build it inside of what's called a studio. And the studio is a clean room environment. It's safe by default, and it will install automatically any dependencies that you need to actually go and build your application. So anyone ever have the problem of you get source code for, or a binary from a developer, and you go and you actually go and try and run it on their machine, and they're like, or I'm sorry, on a production machine or another machine, and it's not working? And then you find out there were some things that they installed on their laptop that you didn't know that needed to be installed in production, right? So the studio hopes to get around that problem by having this clean room environment where you do all your build work inside of that. Any dependencies are automatically resolved by Habitat and pulled in for you. And so this is what it looks like when you build that actual Redis plan. So we'll enter the studio, and then it's going to go and resolve all your dependencies and download everything that you need. So how do you decouple the application build from the final production-ready container? So this is what we do, is that we provide this DSL to describe the application build. So that plan.sh is actually, there's a bunch of different methods, and if you stop by the booth, there's actually a cheat sheet that gives you all of those methods and what those methods do. And all you need to do is override those methods for the lifecycle of your build lifecycle of your application, right? And the resulting thing that you get is called an application artifact or a Habitat package, right? So after I do that build, I'll have a Habitat package containing Redis, and then I can actually take that package and I can go run it. So you take that package, you ship it up into a depot. It's a central location that's publicly hosted, and we have this idea of channels so that you could create different views of what packages that you might want to be using in different environments, right? So you might have, as you progress an artifact up through a different environment, you might have newer things in your staging environment than you do in the production environment, and that's what views provide for you. And if you go to app.habitat.sh, you can see what this actual package looks like, and you can see information about what my dependencies are, my the C application. So what's going to happen is when I install it, it will go and install this version of glibc. And what I've done in this case, I've decoupled myself from the operating system. So I'm no longer dependent upon the binaries or the libraries that the operating system's providing for me. I'm having Habitat actually resolve all of those dependencies for me. Everything's installed by a command called hab. It's an easy pattern that kind of follows this noun action or noun verb type format that we've had in our tools for a long time. So if you've ever used knife, you're definitely familiar with that. And then also, when you install a package, you can have increasing specificity. I'm not saying that right, but we'll go with that. I'm sorry, I had a language thing when I was young, so it's hard for me to pronounce things. I really did. But what you can do here is that you can say, you notice we have core Redis, a version, and then a build number. So I could say core Redis, and what it will do is pull the latest. Or I can be very, very specific, and I'd say I want a particular version. or I can be even more specific and say, I want this particular version that was built on this particular day at this particular time, right? And then that way I can get very, very granular with what I'm doing from a version pinning perspective. And then packages also contain binaries and config. So it has the metadata that we saw, but it also has config. And what happens is you ship that binary and the configuration all in one package. Versus traditionally, the way things, a lot of things that are done, especially in the DevOps space nowadays, is that you ship the application artifact, and then you ship config in something like a cookbook or a Puppet manifest or something like that, right? And then you have this decoupling that happens that you don't necessarily know is the config the right thing that you need for the application at that point in time. In this case, we're shipping them together, right? So all you have to do is say install package core Redis, and it will go and download it from the depot. It'll install any dependencies if they're not there already, and then you're able to actually go in and start the application. And you start the application through what's called the supervisor. So in supervisors, we'll install everything that you need automatically, and that's what we saw here. Well, this is actually the HAB package will install things automatically. We didn't need to actually do that. We could actually just say HAB start core Redis, and it would start Redis for me, and anything that it needed to download, it would download, including the core Redis package for me, right? It makes sure that things stay running, and it also helps manage your configuration as well. So we talk about environment configuration. So there's a couple different ways that you can do environment configuration. So what we do is you have the ability to query any package and find out what its configuration is. So all you have to do is run hab config, the name of the package, or actually HAPsup config, the name of the package, and you'll get back what's configurable about this particular package. And then you can do it in a 12-factor way where you're going to be overriding environment variables, or you can have config externally enforced. So the supervisor comes up, runs, it listens on the network, and then you can inject configuration into that running supervisor to change the live running configuration of that application that you have, right? I'll give you an example of that here in a second. You can also do file configuration where you bake the configurations directly onto the systems as well. So you could have what's called a user.toml, and you embed it inside of your container or on your VM or wherever you want to run this at, and that will also enforce the configuration that you want as well. So the supervisor helps solve this problem of how do I build immutable infrastructure, but how do I still allow for these safe last mile configuration changes. So by being able to go and inject configuration into the supervisor at runtime, or once the supervisor's already up, I'm able to make these configuration changes. This will make a lot more sense in the context of containers when I actually show you how you actually then can take this thing and export it as a container. So supervisors, so every single instance of your running application supervisor, and those instances can talk to one another. So those instances form what's called a service or a gossip ring, and they communicate back and forth, and they share a couple pieces of different information. They share information about the ring itself, so who's the members of the ring. They can also share information about other rings. So rings can talk to one another. You can bind rings together, and then you can share information across rings. So why would you want to do that? Do you ever run maybe a web tier and a data tier, and you have to communicate back and forth, and what does this web tier need to know? Well, where that data tier is, right? And so you can share information, you can bind those two rings together that you would have, and then be able to exchange information back and forth between the consumers and producers of services. Then the other thing about the ring is, actually I'll talk about this here in a second. The supervisor also provide what's called a Rest-based API. And this Rest-based API allows you to do different things. So it allows external actors to query the health of the application. It allows you to go in and find out information about the supervisor itself. And then the other thing that you can do is if you had a load balancer or something like that, it could query the health check and then automatically pull that service in and out based upon the health check response. You can also see some other cool information, which I'll show this to you at the demo at the end. You can also see what packages are installed. So inside of a running instance of the service, and especially if it's inside the running container, you can actually see all of the packages that you installed through exporting that actual container image. And what that allows you to do is query remotely without necessarily having to go into the container or the live running container and knowing what version of a library I'm using. I mean, is that important to anyone? With things like, you know, what's the latest shock one that we have? Or shock bleed, is it? So Heartbleed and other things like that. So you're able to query via this API to actually find out what versions of libraries that you're using, and then maybe go and rebuild your images if you need to. And then the thing that I think is super cool, and I think it's probably most relevant when you're talking about things in the scheduler world, is this ability to support different topologies. And so what you can do is that the supervisors can self-organize. So all you need to do is tell the supervisor that you want to run in a certain topology, and what will happen is as the supervisors come up and begin to communicate with one another, they'll do a couple things. So first, they'll make sure that there's enough supervisors running in the ring to run this particular application, so they make sure that they have quorum. And once that they have quorum, they can do a leader-follower election. So they can say that somebody's going to be the master and somebody's going to be the replicas in the case of Redis, which I'll show that to you at the end. So you don't have to have different container images for the different roles that your application service would play. They can automatically figure that out themselves when the containers launch, right? Or when the application services launch. And then the other thing that the supervisors provide is an update strategy, right? So maybe for some reason you want to have that image updated automatically without necessarily needing to rebuild the image. You can actually have Habitat watch the depot, and when a new version of a package is published to the depot, you can automatically have the live running service update with that new version of the package. You can also, if you're not running inside of containers, this is really useful if you're running Habitat on a VM. So Habitat can run in a variety of different places. It really just requires Linux x86 64-based operating system with a kernel 2.6 or higher. There's an MVP of this running on Windows as well, and we're working on that further. So you can begin to have all of these benefits of Habitat without necessarily going full-blown on containers. And it's also useful if you're doing data services that you might want to be running on a VM. And then you have the container services that are actually communicating back, and you get the Rest-Based API, you get the ability to do configuration management, you get the ability to do the leader-follower and the topologies and update strategies as well. The other super cool thing that we can do is one at a time. So if you have many different supervisors running, they'll do an election to figure out who will get updated first, and then kind of just do a rolling deploy of that application throughout that ring. So how do you orchestrate the application launch order and topology? So we provide a config-aware, autonomous, self-organizing peers with built-in topologies for clustering strategies, right? And then the other thing, which is most relevant to the talk, is how can you actually get this out in a reusable format, right? Or a different packaging format. So what you can do is you can do HAB package export, and you can specify an export format. You can do Docker, ACI, or Mesosphere, which Mesosphere is just a tarball with the appropriate YAML file. You can also export a tarball as well if you just want a plain tarball and you want to deploy that as your deployment mechanism. And then you can just take that Docker image or ACI image and have Kubernetes launch it, and it will come up for you. And you get the benefits of the supervisor. You can inject configuration and so forth. So one thing that I kind of had talked about is this idea of dependency resolution and how we're a little bit different when we go and export that container. So we don't have much layering built in. So we're an early open source project. We're definitely looking for more contributors. We have a lot of contributors inside of Chef. We also have external contributors, and we have some external core maintainers now as well. So if layering is one thing you'd like to fix for us, we'd appreciate that. But when we export it, if you think about how you normally build a container image, what you do is you start with an operating system. You put any operating system libraries in. That's usually apt-get install something, right? And what happens when you do apt-get install? And especially if you're pulling from your operating system vendor's repository. You've now tightly coupled yourself to the release cadence of the operating system vendor. And that's why you have other repos that end up getting set up that have more modern versions of Ruby, more modern versions of Python, or you end up going and creating your own repository with more modern versions that will run on the particular operating system that you want it to run on, right? Anyone still running Rel 6? I'm sure somebody is, yes, right? And what version of Ruby does that ship with? 187 or something like that, right? So really, really super old version. And that's bad, right? You want to control your release cadence, not the operating system vendor. And then you have application libraries and the application itself. What we do when we export a container is we start with the application, and then we resolve all the dependencies, and all the dependencies are provided by Habitat, so you know exactly what you've stuck into that container, and then a very minimized OS, so we just use BusyBox. The supervisor is also installed in any dependencies that the supervisor has as well, right? Letting you take a picture. So if you think about it, what you want is you want to be somewhere on this sliding scale, right? And over here, this is kind of traditionally how we've done things for a really long time, like VMs, bare metal systems, AMIs, all of that. We have a really large operating system, and you're only really putting on a slice of the application. What you want to try and move towards is this idea of if you can, a statically linked binary with virtually no operating system or no operating system, right? There's the blog post from 2014 that Kelsey Hightower did where you just build a Go binary and you're just running the Go binary inside of the container and you're not actually have no operating system at all. You build from scratch, right? And that's the goal of what you want to try and get to. But of course, you can't do that with every single language that you have, right? Not everyone in the world runs Go, right? No matter what Twitter seems to tell you. And so then you can actually go in and see all of these transient dependencies that you have because we're able to build the containers this way. So do you guys want to see this in action? Yes. All right. All right, so I have, make sure I'm still connected. I'm not, of course. All right, so the first thing I'm going to do is I'm going to run a HAB Studio enter. And so what this does is it puts me in that clean room environment. In the case of Linux, I'm actually running in a cheroot. In the case of Mac, you would be running inside of a Docker container. And so I have a whole bunch of different plans. I'm in the wrong directory. So if I do ls, you can see all of the core plans. And these are all the tools that we actually go and publish for you and provide for you, right? So I can go in and look at HAProxy, for instance. So if I look inside of HAProxy, I've got my plan.sh, I have a default.toml, and a config directory, right? So inside of my plan.sh, if I look at it, you can see that metadata that I talked about at the top. You can see where I'm actually going to pull this from. Let my clicker go. You can also see some things. What I'm going to do is I'm going to export frontend.port to port, and then I'm going to status port will be status port as well. You can also see what we expose. So this is actually just something that we're providing if you're going to be exporting to a container format, so you have your exposes set up right. And then we also have something called binds. So this is essentially what we're doing is we're declaring a consumer-producer relationship. And this is saying that I need to bind to something called backend, and I need the port information from the backend, right? And then you can see all of my build dependencies. And then you can see how we actually build and install the software, right? And if you've ever built open source software, it's very familiar, kind of the /configure, make install loop. And what we do is we actually, if you don't override build or install or anything like that, we actually follow that paradigm of /configure, make install, right? And so this will generate an HAProxy package for me. So all I need to do, let me show you one other thing as well, real quick. So by default, I have some configuration that I'm providing as well. And you can see here everything that you would expect, what servers I would possibly want, front-end, back-end information as well. status page, and so forth. So by default, the status page is not going to be enabled, right? By default, the status page is going to listen on port 9000, right? And then what happens is that defaults get put into the HAProxy configuration file. And if I look inside of here, what you can see is a mustache template. And so you can see here is that if status is enabled, then we're going to do this block, right? And so by default, what's going to happen? This block's not going to get in my config file, right? You can also see up here where we have if I've bound to a backend, then I want to iterate through all of the backend members and print this out if it's alive, right? So basically, it's going to dynamically go find out all the members of the ring of the application that I want to load balance, and then print this line in the HAProxy configuration for each of the member that I'm load balancing, right? So let's actually build HAProxy. And so all I need to do is run build HAProxy. And so this is going to take a minute because it's got to download things. But luckily, I'm not running on, this is an AWS, so all I need is an SSH connection, hopefully. The internet here has not been friendly to us, has it? All right, so while this is building, can show you something else. So I actually did build this earlier, so I don't need to continue to show you this. But what's happening is what was my build dependency that I needed? GCC. So it's going and downloading GCC so that I actually go and build the software.
Quick question about
yes.
dependencies. It looked like from your file that all the dependencies were already stated as being from Habitat.
Mm-hmm.
Are they required to be in Habitat, or can you pull from other sources, build from that? Or
It would have to be a Habitat package. Okay. Yep. So it has to be a Habitat built package.
I have another question.
Yes.
So if two people build the same Habitat package, they're going to have a different, let's say, version because the version has the timestamp in it.
Yes. Well, so the different versions, but then you also have this thing called the origin key. So anything core, so that's the beginning part. So you saw core/Redis. Core basically means it's provided by Habitat or it's provided by Chef. And then you create your own origin for the packages that you want to build, and basically your packages will be in your origin name of your package, right? And then if you're sharing an origin, you could actually have two different builds, and they would be two different build timestamps, right? And so you would have to, but people shouldn't actually be building the software, right? What should be building the software is something like a pipeline, and you can make sure that those collisions aren't necessarily happening. But the reason why you want that build timestamp to be different, because you might build the software with different flags from one time to the other when you actually go and actually build the software.
Have you thought about how Nix does it? That it basically hashes the whole dependency tree, the flags, and...
Ian, would you like to speak about Nix? I mean, we have some inspiration from Nix, but because we're not actually all about providing a whole-fledged operating system, perhaps, the paradigm, I don't think, translates cleanly one-to-one always, right, when you're trying to compare Nix and Habitat, right? So, of course, my internet is funny. Can you wave the Wi-Fi puck around a little bit? All right, so I built a package earlier, and you can see here that I've got the HAProxy package. So now what I can do is I can do a HAPsup config kubecon, and I can query this package to find out what's configurable about it. So I don't have the supervisor installed, so it's going to go and automatically do that for me. And so it's resolving all my dependencies. Oh, because I don't have it installed. All right, the internet's not working well. So I'll switch to this other local demo that I have. So let's talk about, so I take that HAProxy package, and then I do a HAB package export, and it'll export it into a container for me, right? So now what we can do is we can actually have the scheduler go and run it. So what we did is we actually took the guestbook application that Kubernetes uses for a lot of things, and we rebuilt it in Habitat. And when I say we, I mean our friends over at Container Solutions did this work for us. Their CTOs in the back. So thank you for the work. And so now we have this Redis cluster, and also if you look at deployments, we also have the guestbook front end. And the guestbook front end is going to talk to the back end. And you can see we have Redis HA. So let me show you the example that is actually kind of cool and pretty powerful. If I go in and look at this log, you can see that Redis is running. And there's master replica set up between the two. So if I look at weave scope, I can figure out who's the master in this scenario. So everyone seems to be talking to this container, so this container must obviously be the master. So what is that, the VVK? So if I go over here and I kill this container, and of course I kill this container, Kubernetes is going to bring it back up, right? No big deal about that. But how's my application going to heal itself, right? And that's kind of the important thing that Habitat will help you do. So if I go over here and refresh, you can see what happens here is that we notice that we've lost connection with the master here. And then you can also see that we go and we start to do a new election, right? And then once the election is done, you can see that Redis brings itself, or Habitat brings Redis back up with the new configuration. And then you can see that the master replicas have begun syncing data once again as well. And if I go over to weave scope, that's not available. You can see that there's a new container, and the new container's taken the role of master, right? And that's all built into the ability inside of Habitat and Habitat Supervisors. Another thing that I could do, we're running out of time, is you could do a HAB config apply. And with a HAB config apply, you point it at one of the supervisors, and you can inject new configuration into that live running container. You can also look at the information in the Restbased API. So this is some of the information that you get from the Restbased API. So you can see what version of the package that a service is running. You can also see all of the other services that we might be binding to. You can find all of my dependencies through this API as well. I can also go directly into the service itself, and I can see what is the live running config of my service. So if you wanted to go and query to see what your config that your containers are actually running, then you can hit the Habitat API and get that information back. So if you're interested in contributing, or if you're interested in working with Habitat, so it's all open source. Everything I've shown today is open source, well, except for software that's not mine. I don't know what Weave's license is. It's all based on the Apache license, and if you are interested in contributing, these are the useful links. There's a pretty active Slack channel. We have almost about 1,000 members now, or a Slack team. So just go to slack.habitat.sh. You can sign up. There's a tutorial that you can do. And as I said, we have a cheat sheet as well. So if you come by the booth, we're right next to VMware and across from Weave. We have a cheat sheet and some other information as well, and you can get all these links on a card for you as well. And stickers, and we have a bunch of t-shirts we're trying to get rid of. So if you want a t-shirt like this, come by. But if you have any questions, I'll hang out outside and we can answer questions that way. Thanks a lot.